So what is chemical change? All of the pictures here I've put up show examples of chemical changes and some of the different things that we might see. One thing we might see that tells us a chemical reaction has occurred are color changes. If you light up a glow stick, the color changes. If I pour this particular clear colorless chemical into clear colorless solution, I get yellow stuff. Light might get emitted or absorbed. The glow stick is emitting light. Fireworks are giving off light. Gas might be evolved, right? You might see something that's steam-like or gas-like coming out of your solutions and out of your reactions. Solids might form. That's what this yellow stuff is in the beaker. The temperature might change. You might notice that a reaction gets hotter or colder. What's important to know is that chemical change is not proven by any of these things. You can see the temperature change on a pot of boiling water when water goes from being cold to being hot and being boiled. That's not a chemical reaction. It's not a chemical change. The water is still water. It's just in a different state. If you take a block of dry ice and you set it out, you'll see that solid CO2 and you'll see something that looks like gas coming off. That's CO2 and water vapor, and it's not a chemical change. The carbon dioxide is the same carbon dioxide. It's merely changed state. So I want you to know that they're evidence for, but not proof. We describe chemical reactions by words and talking about what happens. So I can take a chemical potassium nitrate, KNO3, and I can decompose it. That just means I heat it up a lot. And out of it I get dinitrogen, potassium oxide, and dioxygen. That's what's actually happening in those nice pretty fireworks up there. And that's the chemical reaction. Potassium nitrate decomposes and it gives off a bunch of stuff. What I use from there is a chemical equation. So I use the chemical symbols and chemical formulas to describe absolutely everything in the equation. Potassium nitrate, which is a solid, decomposes, right? So that arrow there tells me change has happened, right? And I started under a certain condition, and I finished under a certain condition. And so when I write a chemical equation, there are things that I'm interested in. A plus B equals C plus D is a very generic chemical equation. These are what we call the reactants. Reactants go on the left side of the arrow. They're what you start with. They react. The products always go on the right side of the arrow, and they're what comes out of the reaction. Let's fill some stuff in. There's a reaction where I can take N2 and gas, right? So this is the formula. And then next is the state, right? States always go in parentheses. And I add it to another chemical in its state, and I make something. I make gaseous NO. Several important points to notice about chemical equations. They have got to be balanced. Equal numbers of atoms on each side. So there's what's known as the law of conservation of matter that says I can't destroy or create any matter in the universe. If I started with 2 N atoms over here, I had better have 2 N atoms on the right hand side. If I started with 2 O atoms, which I did, right, there's 2 oxygens, then I had better have 2 oxygens. I use these coefficients in front of chemical formulas in order to make it balance out. One thing that's not required is reactants and products to have the same state of matter, right? The reactants are gases in this reaction and the products are gases, but if we go back to the previous reaction, the reactant was a solid and the products are gas, gas, and gas. That's okay. States are what they are.